Just to briefly introduce myself, I'm Russell Weller, work for a company called Highcon Systems. I'd just like to spend the next 10-15 minutes before the lunch break just giving you a very high level overview of what we do and what we can bring as an organisation. Just to set the scene, so if you go into any folding carton printer converter, corrugated printer converter around the world, you will see this step. Now it's probably a little unfair to call it old, it's probably more traditional analog type technology. So that's the manufacturing of a die, a wooden die, and they will use that to put onto their die press, on their rotary die press. High volumes, high run lengths, it's very important to their production steps. Will continue to be important to their production steps, but it brings challenges. The cost of the die is a challenge. The lead time, how long it takes to produce these dies, and we see the trends ever changing where lead times are reducing. We talk a lot about today about sustainability, the cutting of the wood, shipping these things around the world. There's a sustainability aspect to the die as well, but it will remain important within inside of the ecosystem of packaging. We like to do something different. We call it new. We don't call it the future because it's here today. We have lots of customers utilising our technology today, and I'll come on to how they're utilising that. But that's converting, finishing with laser technology, not with a conventional, more traditional way of finishing folding carton and corrugated material. So we've seen over the last decades, 10, 20, 30 decades, 10, 20 years, 30 decades, the transition from digital in many aspects of printing. That's within the pre-press world, moving into a automated workflow environment to deliver right time, first time right files to the press much quicker. We've seen it in the world of printing for, again, many decades now in the world of printing. That gets much quicker, the quality gets much better, but they still exist within inside of that analog environment. They can bring value to the analog environment, or it can just be its own digital environment. What does this cause? All of this increase in efficiency in pre-press, all of this efficiency in printing, it causes huge bottlenecks down at that finishing step. And we see that there's digital devices out there that can do with a blade, they can cut, but again, very low volume type sheets in that world of digital. So what do we do as Highcon Systems? We bring a high volume, very efficient finishing device within inside of that finishing department. So that's the devices that we manufacture. They're manufactured are indeed in Israel, where our head office is. We started around 12 years ago with what we call the Euclid. I won't go into too much details on all the products today. And our initial aim was to go into the commercial print, people that are doing decorative finishing, embellishment, that type of environment. And we had some success. But over the last 3-4 years, we've really started to see packaging taking off. So we've evolved our products, we've brought innovation to our products that now really bring efficiency gains within inside of the folding carton and the corrugated. So that brings products like the Beam and a product that we call the Non-Stop, again to bring much more efficiency, the ability to be able to produce more cut sheets per hour on the shop floor, because that's ultimately what we're trying to achieve. If I just break the technology down just a little bit, again, I won't go into too much details today, but this is a look inside of a Highcon device. If I start over at this side, so this would be the printed sheets coming in off of a pallet, and then this would be the converted sheets coming at the back end of the device, again, back onto a pallet. And this bit here really is where the magic happens. So what you first have is the registration station. That can be done with a camera top or bottom, depending whether it's folding carton or corrugated, or it could be a mechanical registration using some sort of lay edge matching what's come off of the press. Then we go into what we call our dart. This is our own technology that we do. This is a mechanical crease, where some technologies out there will crease with a laser, so that would just be breaking down of the fibers, as is a physical crease. And if you just look up there, the dart technology, as we call it, we actually image polymer onto a foil. The polymer is quite soft as we image it, so that's creating the rule line. We go through a UV process to harden it, and then we're actually creating a crease matrix to be able to physically crease that material in line on the fly on the actual press itself. Then we go into the laser cutting stage. So we're creasing, we're cutting, and then we can also strip. So small parts, small components automatically drop out. Don't have to have a manual process at the back end of that, and then we're delivering the finished sheet at the back end of the actual device. That's the technology, that's the process, and that's just a snapshot look inside of one of our devices. So why do we bring this to market? We've looked at the analog way of doing it. I said it's important for customers today, still remains important. We have XYZ cutters out there, they've been out there for 50 years. But what we really see is there's a gap between that XYZ cutter and the analog. And that gap really sits just here. So if we again look at a kind of a traditional type setup at a folding carton corrugated converter, you would tend to see flatbed cutters, mainly used for things like sample making, short run, ultra short run, perhaps in the low 100s, and you may see some cylinders, that type of application. If they wanted to go anything past a few hundred, they would then start looking at more of the analog. This is where you need to start buying a die, take a long time to set up, expensive to run, but perfect on those long runs. The 50,000s, the 100,000s, just keep running all day, absolutely efficient at that type of run length. But again, there remains a gap here at that kind of 500 to 10,000 sheet run. And that's really where a Highcon comes into its own. We bring efficiency gains from that short run. Why? Because we don't have to use a die. It's fully digital. Everything's done on the actual device itself. So there's efficiency gains there. We don't have to wait for the die to be produced. Sometimes they can take 24, 48 hours. We could have printed and finished the job before the die's even been actually delivered to the customer. So that's really where the Highcon sits in between the sample making table and the actual analog die cutter. So we can bring efficiency gains there, we can bring a reduction in lead times, we can really help with the margins on those shorter run type jobs. But what we can also do, and there's a crossover point with anything, we can also bring efficiency gains on this equipment here as well. Why? Well, you're not having to keep changing jobs on that equipment. You're not having to go from a 5,000 run to a 50,000 run. You can leave the long runs on that equipment and you can put the shorter runs in the equipment. So that's why we call it the right machine for the right job, or the right job for the right machine. It's really quite important. And that's without all of the other factors that we talk about, e-commerce and all of the other capabilities of our equipment. Just a very brief overview, I won't go into too much detail. When people think about laser, they think it's very complicated, there's lots of changes that you need to do in your environment, in your production environment. Absolutely not the case. So again, just a typical flow that you would see. So you'd have a job entry, that could be coming into an MIS, it could be an e-store, some sort of e-commerce system, not a problem, we can take that in. We have our own estimation and costing software that we develop on the front of our technology. We work with partners, best in class, in this instance it's Tilia. That would be for nesting and ganging. Again, another advantage to going digital, you can mix jobs on a sheet. That's very difficult when you're in an analog environment. If you're in a digital environment, much simpler to be able to do that. Then we just take your native structural design file, could be coming from the industry standard structural design applications, straight into the front end, minimal setup, and away we go, and then delivering production data at the back end of it. So we're not trying to change the world, we're not trying to change the workflow, we're trying to put a device in which maximizes and really brings that efficiency gain within inside of that existing production environment. So what did it do? Just high level advantages. Customization, we have what we call VDC. Obviously you heard a lot about VDP, variable data printing. We have variable data cutting. Every sheet through a Highcon could be different. Every single sheet could have a different cut profile. In reality, most people aren't doing that. What they are doing is 50 sheets may change, then another 100 sheets it may change, especially with inside of an e-commerce environment. So we can start changing the cut profile on the fly. Impossible to be able to do that in an analog environment, just because of the physical cost of a die to be able to produce that. Time to market, I talked about the reduction in lead times. You can print, cut and get a job out the same day, the next day. Again, very difficult to be able to do that in an analog world. Process improvements, we're helping the processes of the devices that you've already got. We're really making them much more efficient when bolting this within inside of an environment. Making short runs more profitable. Not in every case, but certain cases, certain types of work, absolutely we can help with the margins. And we've heard a lot about this, so I won't go into too much, but we are sustainable. I talked about the die process, the manufacturing. It uses a lot of wood, they're heavy, shipping them around. There's absolutely a sustainability angle when going into a digital finishing environment. Just a little bit about Highcon. I'm sure some of you haven't heard of us or who we are. So the company's just over 12 years old now, as mentioned. We have head office in Israel. That's where the majority of the 130 employees would sit. Most of that is in R&D. We're continuously innovating. We did float, so we're a publicly owned company now. You'll see patents. We have a huge amount of patents on our technology. It is new technology, as I say, so continuously to bring patents on top of that. And again, I won't go through all those numbers, but you can see that this is now really in a production world. We have customers that are heavily utilizing this technology to deliver jobs onto their end customers. Quite an important slide that. There's still a perception in the market around laser. It burns, you get hazing, you don't get the output quality that we need, you don't get the same output quality from analog. Quite an important slide because this is what our customers and who they're producing their work for. So you can see there's some very high brands that are accepting work off of a Highcon, and in a lot of instances they don't even know. So we can get to that same level of quality. So that perception of laser is certainly starting to diminish and disappear altogether. We need to be able to produce an output that's a good enough quality to be able to obviously pass on to the customer. And that's what I say, we're here now, it's not the future, we absolutely can deliver solutions today. Just a couple of applications that customers utilize. So we see displays, customers producing displays for things like lipsticks it's perfect for because there's lots of small holes that need cutting, perfect application for laser. We can strip, so all of that will drop out automatically, no manual steps are needed. And then right through to corrugated packaging, countertop displays, full FSDUs where they're mixed techniques between going onto a die and onto a Highcon. We see customers doing that now. And then also, of course, into the folding carton market. Big customers utilising our technology now into folding carton. E-commerce is really starting to take off. We've seen that in the US, but really starting to now take off in EMEA as well. Again, digital is absolutely perfect for that e-commerce environment. Just a very brief overview of the portfolio. Won't go into any technical details. So as mentioned, really the folding carton and the corrugated market is the markets that we serve and really can bring value. And then it's really a decision around productivity. So the Euclid was our first iteration. Last few years we brought the beam. We have the beam 2C and the beam, depending on the materials that you want to produce. And then Q1 of next year we'll be putting the first non-stop into the US. So that's a fully automatic device. You don't need to change pallets. It's a bottom feeder, non-stop feeder. And even on the stripping, we will take that off on a conveyor belt. So you don't need to stop the machine for anything. It's just a continuous feeding machine. So that's why I talk about production. They're really production-ready devices, and we are developing them for that application. Just last slide, and I think I'm pretty much bang on time. Won't read through all of this. I just want to use this as a good example. As a customer in Seattle in North America called Boxmaker. You'll see there, and again, probably a couple of lines just to point out, this is really quite an important one. So they installed their first Highcon in Feb 21, and they're now on to their third Highcon already. It allowed them to bring new business in-house, certainly on the e-commerce side, but make their traditional work much more productive. And again, you see here around, it's helping them to eliminate the backlog, and we hear that, the bottleneck, the backlog that you have in finishing, we can really start alleviating that backlog that you have.
Had we known...
With that, I think I'm bang on time. Marcus, thanks for your time. I appreciate you want to get to lunch, but thank you very much.
Thanks very much, Matthew. Thank you.